they tell us life over limb. So if you're unconscious, you get them out of the water as soon as you physically can.
All right, lights, please.
If they're conscious, you should do a spinal cord.
Okay.
Get a head injury.
So this unit we're starting right now. So you're going to be very thankful for the TI graphing calculator. Okay? So it's on matrices. Now, let me explain what a matrice is.
The thing from the Matrix where
No, nothing to do with it. Let me see. So this is what a matrice is. Do you remember in Algebra 1 back a few years ago? Let me get to the end of these. Remember in Algebra 1 where you could solve like y equals 2x plus 3 and y equals negative 4x plus 5. And if you graph them, you could see where they intersect. That's not what the graph looks like. I'm just kind of doing that. And then you get an answer. You make your answer as x comma y. And then sometimes you might have had two lines when you graph them that are parallel, which you have no solution. And then you had that real awkward, strange one where you had the same exact line on top of it, so you have infinite solutions. Remember this? This all kind of, this has one solution. Okay? Now, a matrice is just a way of taking a bunch of linear equations and solving for it. Now, businesses will use a matrice to see if you are actually the best fit candidate. Now, I know you've all heard of some of these places where you can put your resume online. Yes? Yeah. You know, like monster.com and things like that. So a lot of times what Monster will do, they will allow you to put your resume up, but then they also have like, you know, a questionnaire that is, you know, like let's say you want to be a mechanical engineer. I'm just saying, so you click mechanical engineer, and then all of a sudden a new list is going to come up saying, hey, do you want industry? Do you want lab? You know, what do you want as far as mechanical engineering? So then you click the ones that you're interested in, and it could be more than one. And then that would then take you to a new screen, which is already pre-slugged for, you know, if you wanted to be a mechanical engineer and you wanted to work in industry, then it opens up, do you want to work in the public sector, the private sector, or the government sector? And you click all that apply there. And then let's say you pick the government sector. Then it'll say, do you want, are you interested in working just in the United States, or are you interested in working in the world? Let's say you pick the United States. And then it says, what states are you willing to work in? And then you select all the particular states that you're willing to work in. And then they might actually have certain types of projects that, or companies that are in those particular states, and you can click on that. And then by the time you get down to feeding all of these questions, you've now developed like a matrix of who you are. And so what that will do then is, rather than some company that's hiring engineers, rather than going through and saying, okay, we have, our company is in Texas, Colorado, and Arizona. Rather than going through all the resumes, finding out who wants to work there, you've already done that job for them. So, you know, it's like, let's say you're like, dude, I want to be in Colorado. Okay, so that company's going to say, hey, you know what, I have a mechanical engineer who graduated from this university who is interested in working in industry, in government in Colorado. Then your resume will go to that company. Okay? So it's kind of a cool network of what's in place. Now, does this save companies time and money? Absolutely. Does companies like Monster make a lot of money off of people's resumes?
Monster doesn't.
They don't do it anymore?
Well, they do, but my mom used to work for Monster, and then she left because they like weren't doing too well. I think they're still around, but I'm sure it's for LinkedIn, and LinkedIn is like.
LinkedIn, yeah. And so LinkedIn's a classic one. I'm on LinkedIn, and it's funny.
You should connect with my mom.
Okay. I get a lot of.
Okay.
It's kind of awkward, but okay. So what's interesting with LinkedIn, because I have a degree in math, and because I have teaching experience, and because my teaching experience includes me teaching all the way through basically Calc A, and International Baccalaureate, and statistics and things like that, as well as running the medical class, I have different places that contact me. Now, Denver Public Schools, they have a charter school that has opened. These are the last ones that contacted me saying, hey, we'd like to meet and talk with you about a position in Denver Public Schools at this particular charter school. And I, just to stroke my own ego, I will reply to it and say, hey, so what kind of package are you looking at bringing me in at? And then they replied back, well, what are you looking to get? Well, I know if I work in a charter school, there's not a retirement program that we have like with state retirement. So I will put forth, I think I put forth, I said, if you can match, what I'm making here, including what my retirement is, we might want to talk. And they're like, well, what is that? I said, if you can come in at 130 or above, we'll talk. I'm sorry, we can't match that. Okay. Sweet. I mean, I just leave it like that. I mean, am I chasing money? Sure. Is that something that you might do in your career? Do I want to leave Cherry Creek School? No. But to stroke my ego, I'm just interested to see if someone's gonna, we'll give you $500,000 to come over. That might make me consider strongly saying, it's been good seeing you. I'm out. Because someone's going to willing to pay me an ungodly amount of money. So it's kind of a fun little thing, and companies use those different types of websites to figure out what their employees should be or who they should look to hire. If they're looking for somebody who has a degree in math and somebody who has experience in this and this and this, if I hit all those icons on LinkedIn or whatever other site, a company might contact me. Do people leave companies all the time and search out somebody else? Yeah. I mean, your parents probably, since your day you were born, they might not work the exact same company or position that they started at when you were, little babies. Okay? Does that mean anything's broken? No. It's a fair market system. Okay? And it's something that I know that you all will one day start investigating. Where should I work? Where should I start my career? I don't know. I know you are all intelligent people, so you'll start your career in a cool place. But so let's go back to what this matrix is, or what this is a system of linear equations, right? A system meaning I have more than one linear equations. Well, what if we had something that was bigger? Let's say we had so now you're talking about a three-dimensional line, okay, XYZ axis. Let's go further. So now you're talking about a line that exists in the fifth dimension. You're like, what's the fifth dimension? Well, it's WXYZ, or I guess this should have been AW. I'm sorry. AWBX. So WXYZ, and then a constant. Okay, and then you can keep going and keep going. You can get into these incredible things of these matrices. Now, you've all seen a movie that has used some sort of things that move, and it's math that moves. Okay, so let's take. Have you ever seen any of the Terminator movies?
Yeah. With Arnold Schwarzenegger?
Yeah. And you remember the one where they had the one Terminator that came back who was like liquid?
Yeah.
Remember him?
The goo dude.
So, yeah, the goo dude. So, let's say this is the goo dude, okay? And let's say he wants to morph into a puddle, okay? So you understand what I'm saying? So with the magic of math and the magic of computers and the magic of movies, what they can do is say, okay, we want to show the iteration that shows this guy melt into this. Okay, they actually didn't melt somebody, but what they did is said, okay, I'm going to take this point right here, and this point's going to match to here. This point here matches here, here, to here, here to here. And, you know, I'm not going to draw the number of points that really exist. Yes, that's why we have computers, because they do iterations a lot faster than what Mr. Stirrup does. Okay, but let's say they had all of those points to morph to there. What they're going to do is they say, okay, matrices, what we want you to do is we want you to go from this type of thing to this type of thing, and we want to show the math that's taken place. And if you show the math that takes place, it allows this person to melt into a puddle or melt into whatever, change into whatever shape that the creators of these movies want us to do. And then they might say, hey, you know what? We want this puddle now to match up with, I don't know, a box. And again, I'm not being all that creative, but they're going to do the same thing. We're going to take this point here, this point here, this point here, so on and so forth. So this is all being a matrix operation to get there. So we went just from being, taking our resume and finding a place of business to, Hollywood. Okay, so matrices are used very often in places that you all will experience, whether it's through a resume with a company or your entertainment at home or at the movies.
But we're not living in one?
No, we're not living in one. Okay? Because I'm not seeing you morph into anything. Okay. Well, I'm not seeing you. He's not becoming a puddle.
You don't know that.
So that's basically what's taking place. Now, other things on matrices is you can do things like this. Okay? So this is, if I name this, this is a 3-row by 2-column matrices. So we name that matrice a 3 by 2. But let's say I wanted to multiply this matrice with a 3 by 3. Okay, 3 rows, 3 columns. You still with me? So this is a 3 by 3 matrice. And if I multiply these together, I can multiply one way but not the other. So I can't multiply this one times this one. I have to multiply this one times this one in that direction. Okay? The reason is I can take my 3 by 3 matrice and I can multiply it with my 3 by 2 matrice, and my inside dimensions have to match. Okay? If they match, that means you can multiply. And then I can get my result, which will be another 3 by 2 matrice. Now, by hand, this is a 5-minute problem with a lot of arithmetic. With a calculator, you know how to plug it in and hit times, and it's there. Okay? So the math that takes place here is, let's see if I can get this right. So we're going to get a 3 by 2, so I'm going to go. Okay, and then I'm going to go. I screwed up. One more time. 4, 5, 4, 1, 6, 2, 1, 8. Okay, so this is going to give me my 3 by 2 eventually. So I'm going to go 3 times 3 plus 4 times 1 plus, 5 times 4. And then this will be 3 times 2 plus 4 times 6 plus 5 times 7. And it just keeps repeating. That's a 3.
How long does it take a computer to do a problem like this?
As fast as you can type it in. So, does everyone see a lot of single-digit multiplication and addition? So doing matrices by hand makes you incredibly fast with arithmetic. Okay? And so if I were to do this problem, I'd get 9 plus 4 plus 20. 9 plus 4 plus 20 is 33. And then 12 plus 2, or 12 plus 1 is 13. 24 is 13 and 24 is 37. And then 6 plus 1 is 7. 32 and 7 is 39. And then this one's going to give me 6 and 24, that's 30, plus 30 is 65. And that's 8 plus 6 is 14, plus 42 is 56. And then that's going to give me 24, that's 28. 28 plus 56, can't do it in my head, I'm sorry, I'm limited. So my answer to this problem is this. So can you see how this could be really big math?
What do you do with it after you get the
That's the answer, it's done. That's just multiplying. That's just multiplying matrices together. Thank you for asking. Okay, so with that, does everyone agree this looks like kind of a big problem?
Mm-hmm.
So I got to tell you, when I took linear algebra in college, it was Math 342. This is beyond calculus, and this is a class we actually offer here at Creek. Not all kids get there because you have to be on Calc 3 and differential equations. Then you get to this. When I took it as a sophomore in college, we had to do this all by hand. Okay, and they weren't nice. Okay, are you good on number one? Are you doing the paper version? Yeah. Okay, cool. All right. Now there's other things that come with matrices as well. There's other things that come with matrices as well. And so how many rows, how many columns does this have? It's a 3 by 3. Does everyone feel comfortable saying that?
Yeah.
So if I wanted to find what my value of my matrix is, like how much it holds to a number, there is a whole number out there that exists. So if you wanted to find your version, you wanted to find the determinant. The determinant works with a square matrix. Square matrix meaning it has the same number of rows, the same number of columns. Does that make sense? So your first move is you go plus minus plus. Okay? And then you go 3 times 2, 4, 1, 7, minus 2 times 6, 4, 4, 7, plus 1 times 6, 2, 4, 1. Okay, so now I've taken my 3 by 3 and I broke it down into 3 2 by 2s, and it has something called a scalar value outside, which is the 3, the negative 2, and the 1, and you multiply that in. So then if you get through this, you want to work this out, that's plus minus, and that's plus minus, and that's plus minus. Okay, so that what you do here is you go 3 times 2 times 7 is 14, minus 4 times 1, which is 4, minus 2 times 6 times 7 is 42, minus 16, plus 1 times 6 times 1 is 6, minus 8, and then you do the arithmetic. So this looks like 3 times 10, which we can say is 30, and we can go 2 times, is that 26? Did I do that math right? I think I did it right. And then plus 1 times negative 2. And then the arithmetic takes place, I get 30 minus 52 minus 2. So I get 30 minus 54. So the value of this matrix is negative 24 if I did my arithmetic right. Well, that's the sum of 2 cubes. So that first part's right, this part's not. Okay, so this particular matrix has something called the determinant value of negative 24. Okay, so what does that really mean? That just means that's the determinant value. Okay, and again by hand, could you imagine a 4 by 4? Your 4 by 4, you're breaking your 4 by 4 down into 4 3x3s. You're breaking each of those 3x3s into 3 2x2s, and we start running out of space real quick. Okay, 5x5, 6x6. When I was in linear algebra, I remember the very first test. I was panicked by the test because you have to be quick at arithmetic. And then we had a 40-minute period of time, and we had 6 problems on it, and I got done with number 3. Okay? So I had a 47% I got on my first matrix test. It was based on a bell curve, so it turned into an A. Okay? Because that many more people did worse than me. I did 2 standard deviations above the average score and got an A. Huh? Yeah, the average score on that test was probably about a 21, 22%.
You said you only did 3 problems.
So I got half of them. And I got half of them almost right. Because I got a 47%. I probably made a sign error someplace. Which, can you see how you could drop a negative pretty easily? And that's just a 3x3. I remember the third problem I worked on was a 5x5, which you have to break your 5x5 into 5 4x4s. You break each one of those 4x4s into 4 3x3s. Break each of those 3x3s into 3 2x2s, and then you do the math.
Wow.
You know,
How do you remember that?
Why is that?
huh?
How do you remember the
I just
exact
remember
problem?
I just remember going, dude, I can't believe he gave us this big of a determinant to do. I mean, the determinant that big easily takes 15 minutes. And that's if you're quick at arithmetic. If you're like going, counting on your fingers, it ain't gonna happen. Okay? So, you have been blessed with the graphing calculator. So let's get into the beginning of this. So we're going to start working on an understanding of this. Let's see, let's move that out of place. So a matrix is a rectangular arrangement of numbers in rows and columns. So that over there would be a 2-row by 3-column matrix. Agree? So the dimensions, if we were to name this matrix, this would be a 2x3 because I have 2 rows and I have 3 columns. Okay? The 2x3 doesn't have any numerical value other than that's how you would name the matrix. You name it by the rows and columns. Okay? So that's the ins and outs of that so far. Can I move on?
Yeah.
Okay, and I think this next slide says, hey, what are the dimensions? I have 1 row by how many columns? So that's a 1x4. What about this one?
That's a 4x1. That's 3x1.
3x1. Okay. So I have on the top one, 1 row, 4 columns. On the next one, I have 3 rows, 1 column, and that's how I name those numbers. Okay. So we'll probably have you'll have to be able to name these by rows and columns, and that's pretty much all there is to it as far as this part goes. Can I move a little further forward?
Yes, sir.
Okay. Let's see. I have this little blot here. Can I move that blot? What's this? I think this says a square matrix has the same number of rows and columns. Okay? So that top one is a 3x3. This is looks like a 3x2. And blank matrix is a matrix whose entries all are.
Wait, wouldn't that be a 2x3?
3 rows, 2 columns.
Oh.
Let's see, do I have anything here? That are all. I can't move whatever this is. I don't know what that's supposed to be. All right, we named it. Let's move on. It might be called an augmented matrix, but I don't know if that's the term. Okay, when would two matrices be equal? Well, when you have the exact same values. So what would be equal to this 2 by 2? Okay, so that's the same thing as -1, right? That's -1, and that's 0.75, agreed?
So it's the bottom.
So this one works. And let's see, this one is not because that's not in the right rows and orders.
Well, this one.
And then this one actually is as well. You know, like, how can that be the same? So the big thing with matrices is you can take whatever row and you can just move rows like this. Okay, and the reason you can do that is because if you graph y equals 2x plus 5 and y equals 3x plus 7, it doesn't matter which one you graph first. Okay, so you can take entire rows and switch entire rows. Okay, take everything with it. Yeah.
Doesn't that mean that the first one would be good then, or it wouldn't be good?
Oh, no, yeah, you're right. That one doesn't work because, yep, sorry about that. Oh, man, you know, I was sniffing glue earlier.
Oh.
Middle one works, 5-0.
Yeah.
5-0. Oh, that one works. Oh, see, if you guys weren't here, I would just be making errors. So those are equivalent. Those are equivalent. I'm sorry, 5-0. -1. Perfect. All right. 5-0. All right. So when we subtract matrices, I think I have stuff I can move here. Yes, I do. I can move that out of the way, and I can move that out of the way. And it says matrices can be added together or subtracted from one another if you have the same dimensions. Okay? So if I needed to add this one together, I'm going to go 3 plus -4 is -1. -5 plus 6 is 1. 4 plus -9 is -5. Okay, this one can be subtracted because they're both 2 by 2, so I get 4 minus -7, which is 4 plus 7, which is 3. -7 minus 7 is -14. 3 minus 2 is 1. And 0 minus 9 is -9. So you add and subtract part to part. Okay? So the same place adds or subtracts with the same place on the other matrices. They have to be the same dimensions to add and subtract them. I just added single digit numbers. So this and this go together. This and this go together. This and this. And this and this go together. Cool? And then same thing here. This goes with this. This goes with this. This goes with this. Cool? Everyone feel comfortable so far? Wait. Ready?
Yeah, buddy.
Okay. All right. So which matrices can be added and subtracted? Well, I could add
A and E,
these two together,
D and B,
and then I have a 2 by 3, and these can be added together.
and then C and D.
And then C and F cannot be added or subtracted because C is a 1 row by 4 column, and F is a 4 row by 1 column.
So you can't just like flip it on its side.
You can't. Because these are all X values, and this is W, X, Y, Z. So A and E can be added together, and B and D can be added together or subtracted because they're the same dimension matrices. Can I move on? All right, scalar multiplication, all you do is this. It's just distributive property on steroids. So I multiplied -4 times 2, -4 times -3, -4 times 5, and -4 times 0. And this one, same thing. Multiply everything by half. Cool.
You say 7 halves, not 3.5.
I would keep it as a improper fraction. A reduced improper fraction.
Okay, but like what if the half was 0.5?
Then I'd make everything decimals. Yep. Can I move on?
Yes, sir.
Okay. So now, you guys ready to see how the calculator works?
Please show.
All right. So I'm gonna put this matrix in first. Ready? So you find the matrix key. My matrix key is right here, the second of the x to the minus 1. Does everyone have? So second x to the minus 1. Everyone there?
No. Yeah, buddy.
Good? Are we good?
Yeah, buddy.
All right, we're going to move over because we want to edit. And we're going to take care of matrix A. And it looked like matrix A was a 2 by 2. Agreed?
How do you get the 2 by 2?
So go over to edit.
And I got it.
Oh, then you type the number.
And then you type the numbers in. Exactly. So where am I on slides? There. Cool. All right, so I have my numbers. I'm not worried about the scalar outside. I have 2, -3. Make sure you're using that negative down here, not the subtraction sign. Enter. 5, 0.
I thought we were doing the 6, 2, -3, -1.
Oh, did I go? I went to the wrong one. I'm so sorry. All right, so so nice thing is this allows me to edit. So 6 here, 2, enter, -3, enter, -1, enter. Is that matrix C right? Okay. So I'm going to go back to second x to the minus 1, and notice that letter A says this. If I hit enter right now, so quit out of it, go back to second matrix.
Oh.
Okay, go like this. Go second quit, second matrix, number 1, enter. Bless you. Okay. Do what?
What's second quit?
Oh, yeah, it is.
Second and mode. Second mode quits out of what you were just working on. All right, let's make the other matrix C. So second matrix takes you back to that screen.
Wait, how do you edit
Okay, so when I'm going to edit, I'm going to do this. I'm going to edit. I'm going to move down to my 2 by 2, this one numbered B, and now I'm going to do another 2 by 2.
You take the negative that's outside the second part.
Nope, leave that subtraction sign there, and just plug in 2, -3, 7, and 1. Hit second quit, second matrix, and notice that. Okay, so let's quit out of this for a moment. Second quit. So I'm going to go 5, and I'm going to multiply 5 times second matrix, my first matrix C, minus my second matrix C. So that means I'm going 5 times my first matrix C, so 5 is a scalar, and I'm subtracting my second matrix C. And you hit boom. And there's the arithmetic that just took place on the calculator.
Wait, did you do 5A?
5A means that we go 5 times A, and then minus matrix B.
Yeah, I typed it.
This is so fast.
Wait.
What's that?
That's it, sir.
We're gonna get so hard though.
Second quit. 5. Second.
This is fast money.
A.
Tell me that's wrong.
And then minus matrix B.
Yeah.
Cool.
Do you have any scratch paper?
No.
Okay. All right, we good so far?
Yeah.
All right, let's go to problem number 6. Number 6, I'm dealing with 2 different, what are my dimensions of both those? 2 by 3?
2 by 3.
All right, so I'm just going to write over my matrices. So I'm going to go second matrix. I'm going to edit, and I'm going to edit problem number 1. Notice that's still there, so I'm going to go 2, enter, 3, enter. So now it's a 2 by 3, but it still kept my old information.
That's not good.
So now I just want to write over it. 8, enter, -2, enter, 7, enter, And then I'm going to go 3, enter, 2, enter, and -5, enter. So now I have the 2 by 3 that's now stored in my memory. Okay, move on.
Yeah.
Second, quit, because you don't want to stay in the matrix mode. So now you're going to go back into second matrix again, and I'm going to edit my second matrice. I'm going to turn my second matrice into a 2 by 3. And of course, you could have put this down on the screen. That would have been fine. And so it looks like I have -9, 3, 6, -18, 0, and -12. Yo, you jumped on us already, huh? Okay, so then I quit out of that, and I'm going to go matrix A, plus, looks like 2/3 I'm doing with. I'm actually going to put 2/3 in parentheses. Someone's running upstairs, made me seasick. So that I put that 2/3 in parentheses. The reason I did that is if you didn't, it's going to take the 3 and multiply it as a scalar. So it's going to kind of goof things up. So we do that, and I'm going to go second matrix B. Boom. Pretty quick, pretty easy. Okay, one slide left. I have one slide left. I can do it. And everything's going to be on the calculator on this. Okay, so we have 2 times this quantity, agreed? Okay, so what you should kind of look at this and realize is this and this and this go along with that. So I have 2, 3x plus 4 equals 26. And then this and this and this go together. So I had 2 times 5 minus y equals 8. And that's just algebra 1. Okay? And then you would work that out. And I keep meaning to start out a review. Remind me tomorrow, first thing I do is the review. I'm sorry, I didn't mean to skip it. And so I think you should have, I think you can do worksheet 7A, and let's have us do the evens.
Yeah.
Just evens. So that's 2, 4, 6, 8. Peace out. Have a great day, everybody.
And the odds, but it's just-
Peace out, bro.
Yeah, man.